Okay, let's get started on Module 5, Lesson 10. We have some fluency here. Mr. Burke, it's April 2nd, 2020. No more April Fool's jokes. You may not see Bo Jerk today, but you might. You never know. Module 5, Lesson 10, fluency practice, multiply decimals. All right, so I'm going to give you a minute to get that first row, or maybe all of them, copied down. So we have 2 times 2, that's just 4. 2 times 2/10, that's 4/10. It's helpful to remember that we are also talking about that, right? So it's 4/10. These are equivalent. 2/10 times 2/10, that's 4/100. And it is helpful to remember that here we're talking about 4 over 100, right? So if you're confused about where these decimals are going, that will help you. This thinking of the decimals as a fraction will help you. 2/100 times 2/10, that's 4 thousandths. Whoops. Whoops, can't get that right. 0, 0, 4, and then it's ran out of space. So 2/100 times 2/10 is 4 thousandths. So 2 times 2 is 4, 100 times 10 is 1,000. There's also just the trick. 3 times 4 is 12, 3 times 4/10. There's one decimal place, counting from the right. This is the shortcut, remember. If there's one decimal place in the problem, then there's one decimal place in the solution. So there's one place there. 3 times 4 is 12, right? But you could also think, repeated addition, 4/10 plus 4/10 plus 4/10 is, 12/10, which is 1 and 2/10. Just thinking about fractions. All right, so 12 again. And if I'm counting, it's 1, 2 decimal places. So it's 0.12. And here, again, I don't quite have enough space, but it's 12 thousandths. Okay. And then 35, 3.5, 35 hundredths, and then 0.035. So 5/10 times 7 hundredths is 35 thousandths, right? So that's 35 thousandths in a decimal. Okay, so that's one thing I wanted us to look at. Here is another. Let's look at mixed numbers, turning mixed numbers into improper fractions. So 2 1/4, I want to make an improper fraction. So an improper fraction is just as the numerator is greater than the denominator, and the only thing that's improper about it is that the numerator. It's a perfectly good fraction. It's just that the numerator is bigger than the denominator. I'm going to pause this for 1 second. Oh well, I didn't realize that the web camera was on, and people would see that I'm wearing my frumpy pajamas still. But that's okay, I guess. It's just a sweatshirt. So 2 1/4 turning into an improper fraction is. So this is 4/4 is 1 whole plus another 4/4. So that's the 2 plus 1 more fourth. we have 4, and 4 is 8, and one more is 9/4. So there's your improper fraction. And here, how many halves are in 2? 2 halves, that's 1, plus another 2 halves, that's 2 wholes, so 2 wholes, plus 1 half is 2, 4, 5 halves. 5 halves. There's your improper fraction. And then there's the shortcut, right? The shortcut is just multiply the denominator times the whole number. 3 times 4, that's 12. Add 2 more, that's 14. So 14 thirds. So that's 3/3 plus 3/3 plus 3/3 plus 3/3 plus, that's 1, 2, 3, 4, 2/3. 3, 6, 9, 12, 14. And then finally, just changing or multiplying these mixed numbers. So I'm going to use the shortcut for the sake of time here. 2 times 3, that's 6 and 7. 7 halves times 6, 7 halves. Wait a second, those are the same. That's 49 fourths. 49 fourths. I think that's, let's see, will 4 go into 49? I don't think it will. Not 2 either. Okay, I think that's already reduced. How about this one? 9 10/3 times, that's a 4. 8, 3 is 11. That's 11 fourths. That's 110 twelfths. And that one is divisible by, let's see, 2 definitely, 4 or 6. Let's just start with 2. That's 55/6. That looks right. Okay, so that is our fluency activity. Okay, application problem here. Heidi and Andrew designed 2 raised flower beds for their garden. Heidi's flower bed was 5 feet long by 3 feet wide, and Andrew's flower bed was the same length but twice as wide. Calculate how many cubic feet of soil they need to buy to have soil to a depth, of 2 feet in both flower beds. All right. So we read, draw, write. And you have to read it a couple of times to begin to make sense of it. Heidi and Andrew designed 2 raised flower beds. All right, so this feels like the volume activities from earlier this week. Heidi's flower bed was 5 feet long by 3 feet wide. So that gives me 2 of the dimensions that I need, 5 feet long by 3 feet wide, to find the volume of her flower bed. And Andrew's flower bed was the same length, so that's 5 feet. So Andrew's flower bed, now I have 1 of the dimensions I need. Same length, but twice as wide. All right, so his flower bed is 5 feet by 6 feet. Calculate how many cubic feet of soil they need to have soil to a depth of 2 feet. All right, so that's there's a missing dimension in both Andrew and Heidi's flower beds, and it looks like it's 2 feet for height. But to have a depth of 2 feet in both flower beds. Okay, question mark. Okay, so I read it twice. I have a general idea of what it's asking me for, so I'm going to start drawing, see if I can make sense of this. I'm definitely going to draw Heidi and Andrew's flower beds. And Heidi told me that it was 5 feet. The question said it was 5 feet long. So there's my length, and 3 feet wide. So we'll say that's 3 feet. So it's 5 feet by 3 feet. Okay, except I don't know what the height is right now. And Andrew has a similar flower bed, only his is 5 feet wide by same length, but twice as wide. It's twice as wide, right? So it's going to be 5 feet by 6 feet. So it's still 5 feet wide, and we'll just make this twice as long. Was that twice as long? There we go. So this is 5 feet, 6 feet. Again, we don't know the height we're talking about. Calculate how many cubic feet of soil they need to buy to have soil to a depth of 2 feet. Okay, so a depth of 2 feet, that means that this is 2 feet. So 2 feet here, 2 feet here. All right, so now I can find the volume of both of them and add them up. Okay, so volume of Heidi's flower bed is length times width times height. So 5 times 3 times 2, 15 times 2, that's 30, and this would be cubic feet. And, whoops, ran out of space. And volume of Andrew equals length times width times height. That is 5 times 6 times 2. That's what, 30 times 2. Yeah, I mean, of course, it's we doubled one of the dimensions, so it's going to be twice as much. So that's 60 cubic feet. And 30 cubic feet plus 60 cubic feet is 90 cubic feet. So the final answer would just be they need to buy, thank you, they need, whoops, definitely can't see that. They need to buy 90 cubic feet of soil. Their flower bed. All right, so there's our application problem. Objective, so what we need to think about for the rest of the period is, I wrote it in a better way here. Where did I put it? Objective. I will find the area of rectangles that have, so again, area is different. I mean, that's, we were starting to think about volume, so now we're talking about area. I'll find the area of rectangles that have what do I want to say? That have fractional side lengths. So fractional and whole number side lengths. All right. Well, that's where we're at. So finding some areas.